Venn diagrams with probability. Let the probability of z equal 0.47, the probability of y equal 0.24, and the probability of z union with y equal 0.57. Find each probability. For A, they would like us to find the probability of the complement of z intersection with the complement of y. Said in other words, find the probability of not z and not y. This intersection symbol can be translated into and this complement symbol can be translated into not. The complement is not. The idea of remove, do not include, everything but, not, all that is the idea of the complement. So we're looking for the probability of not z and not y. So draw your Venn diagram for those symbols. And this is what it looks like. So we have our two sets, z and y. Probability of the sample space is 1. Remember, the sample space is the universe. And the universe always has a probability of 100%. Or you could say 1 in decimal form. This Venn diagram describes the question they gave us. Notice it does represent it. Probability of not z and not y. In other words, do not shade z nor y. Over here we have the union of z and y, and we're going to need it for the problem. That's why we put it here. And remember, the union means you include everything they have to offer. So we shade all of the z and we shade all the y. So going back to their question, we would like the probability of not z and not y. So it would be the universe, which is 1, remove the union, and this union information, they gave it to us in the beginning of the problem. So it's 1 minus 0.57. And that would give us a probability of 0.43. In percent, it would be 43%. For B, they would like us to find the probability of not z union with not y. So what you do in this case, you draw a Venn diagram just for the z part and then just for the y. So the probability of not z means do not shade z. The probability of not y, that means do not shade y. Shade everything else. Now the union means you put them together and you keep what they both have to offer. So this is the way the Venn diagram would look. Now that you have the Venn diagram, we're going to describe it so we could be able to use the numbers. So this Venn diagram has everything shaded except the overlap, the intersection. So if we could find that number for the intersection, we just say 1 minus the intersection, and they'll give you the shaded region. So notice our question is everything except the intersection. So you write this formula down. We need to memorize this formula. And this formula is convenient because it has an intersection place. And we're looking for an intersection. We know this information, they gave it to us. We know this one, we know this one. This is the one we're looking for. So isolate the intersection by moving these numbers, adding them and moving them to the other side. So we're isolating the intersection part. So you move the 0.71 by subtracting, just do it on the other side. It cancels here. So this is what we have so far. You could cancel the negatives with a multiplication of -1 or division of -1. And finally, we know what the intersection is worth. It's worth 0.14. Now that we know the intersection, we could finish answering the question. So we need everything shaded except the intersection. So it's 1, which is the universe, minus the intersection. And this, which represents the shaded region, is 0.86. That's the probability of the shaded region. For C, they would like us to find the probability of not Z union with Y. So draw a Venn diagram for the Z part and then one for the Y. So probability of not Z. That means all the shaded region. In other words, everything that's not Z. So do not shade Z. So you shade everything else. This one is shade Y. So you shade the Y. Now we're going to form a union, which means take what they both have to offer, and that's this diagram. So now that you have this diagram, this is the question diagram. This is the one that's going to answer our question. Now describe this one. This one would be remove this little piece from the Z. Notice not this little piece, but just this part, this region from the Z. So we need to find a number for this region so we could remove it from the universe and be left with the shaded region, which would be the answer. So this region, the unshaded is 0.33. The whole Z is 0.47. So notice 0.47, which is the whole Z, minus the intersection, which we already know, gives you this 0.33 for this unshaded region. So now we know the unshaded region is worth 0.33. Now we could go on with the problem and answer. So they were asking this question. And this diagram represents that question. So 1 is the universe minus the unshaded region will give you the shaded region, which is 0.67. For D, they would like us to find the probability of Z intersection, or and if you like, Z and not Y. You could read it like that. So now describe each one of these. So the probability of Z, that means the Z is shaded. The probability of not Y, that means the Y is not shaded. Now that we have these two diagrams, we use the intersection of these two diagrams. You're asking for the intersection. Intersection means you just keep what they both have shaded in common. This is what they have shaded in common. And this represents the question we need to answer. So now we need to find out how we're going to find a number for this. So if you look at it, it would be the Z minus the intersection. So whatever Z was worth minus the intersection number will give you the shaded region, which is the question we need to answer. So the probability of the Z, which we have the probability of the intersection of Z and Y from a previous step in the problem. So take the Z, remove, that means subtract the intersection part, the overlap part, and that gives you 0.33 for the probability of Z intersection with the complement of Y.